Hi Math, I'm Andy. Today we want to look at scientific notation and how to add and subtract those really big numbers and those really small numbers. So let's start with the example 8 times 10 to the fourth minus 6 times 10 to the fourth. So we're taking this really big number, 8 times 10 to the fourth, and we want to subtract this really big number, 6 times 10 to the fourth. Now, how I want us to think about this is that phrase, like terms. So think of 8 times 10 to the fourth. Let's look at an example like 8y minus 6y. Now, because the y's are the same variable, we can subtract the coefficients 8 minus 6. 8y take away 6y is equal to 2y. So when we're looking at scientific notation, we notice that we have times 10 to the fourth and we have times 10 to the fourth. And so that times 10 to the fourth is going to be seen as a like term. So when we want to subtract 8 times 10 to the fourth minus 6 times 10 to the fourth, we're really just going to subtract 8 minus 6 and then still have times 10 to the fourth, because this is really representing a placeholder. And so 8 times 10 to the fourth and 6 times 10 to the fourth are going to be in line in that same place. But what happens when our powers are different? Let's look at the example 7 times 10 to the fifth, and let's take away 4 times 10 to the fourth. So now we see that our exponents are actually different. I have a 7 times 10 to the fifth and a 4 times 10 to the fourth. Well, using scientific notation, really what we want to do is we want these numbers to be the same. And so what I can do is I can add a power of 10 to this 4 times 10 to the fourth. I can add an exponent, a power of 10, and what that's going to cause me to do is to rewrite the 4 so that it is to the power of 10. So let's think about this just really quick. 4 times 10 to the fourth is equal to a 4 with 4 zeros. Now, I know that my decimal would be here. I want this to be a number that I'm going to move my decimal 5 places to the right to get the same value. So if I look at this decimal and I move it 1, 2, 3, 4, 5 places, I get the number 0.4. So 4 times 10 to the fourth is going to be the same as 0.4 times 10 to the fifth. So because we added a power of 10, we moved the decimal to the left to compensate for that extra power. Now I can take 7 times 10 to the fifth minus 0.4 times 10 to the fifth, and I can treat these sort of like coefficients of like terms. 7 take away 0.4 is going to be 6.6, and then times 10 to the fifth. So the trick here is to make sure that your powers are the same, and when not, we have to add or subtract some exponents and we have to compensate. Let's take a look at one more example. Let's do the example of 8 times 10 to the sixth, and this time let's add it with 4 times 10 to the fourth. Now in my previous example, I took an exponent and I bumped it up. This time, let's take this exponent and let's bump it down. So I want it to match with a 4, so I need to take 2 away. So I want to rewrite this number 8 point something as a 10 to the fourth. Well, when we bumped up our exponent, we had to move the decimal to the left. So when we take an exponent down 2, we're going to have to move this decimal 2 places to the right. So I would end up with 800 times 10 to the fourth plus 4 times 10 to the fourth. And now my exponents match, and so I can add the numbers like I would add coefficients. 800 plus 4 is 804 times 10 to the fourth. Now, as far as a final answer is concerned, because we are writing our numbers in scientific notation, we may notice that 804 times 10 to the fourth doesn't fit that definition, because you want this number to be bigger than or equal to 1, but less than 10. So what I need to do is I need to kind of rewrite this in scientific notation. So I'm going to take this decimal and I'm going to move it back to the left 2 spaces, so it becomes 8.04. And because I moved it left 2 spaces, I need to compensate by adding some exponents. So I'm going to get 8.04 times 10 to the sixth. And we can do this by figuring this out. 804, and I move the decimal 4 places to the right, will be the same value as 8.04, and I move the decimal 6 places to the right. So one thing to kind of notice is I used the higher. My final answer was in the higher of the exponents. Just something to consider. Whenever you have a final answer, always make sure that it's written in your scientific notation term.